We're now going to talk about the expansion valve or orifice tube and the evaporator core in the system. This is the cold side of the system. This is where the actual cooling part begins to happen. It starts to happen in the expansion valve. So let's talk about the expansion valves that we see in the truck world, in the automotive world. They look like this. This is a diagram of it. We're looking at the bottom side of it. You have the high pressure liquid refrigerant that comes in from the receiver dryer, and it all backs up against that center section. So this is the expansion valve, is the break between the high and the low side. And the way that this functions is that it backs up the high side pressure working back towards the dryer. In the center there is a metering device, a metering orifice, so it lets just a small amount of refrigerant through to go on into the evaporator. And when you meter that refrigerant flow going through there, you drop the pressure and you drop the temperature. And when you drop the pressure and temperature of that refrigerant, it begins to boil. That goes back to the boiling point that we talked about earlier of refrigerants. Something that's very cold at negative 15 degrees. So you don't want any water in the system at this point, or it'll begin to freeze. So as that refrigerant passes through there, it comes out of the expansion valve in somewhat of an aerosol type consistency, kind of a half liquid, half vapor, because it starts to boil immediately. That refrigerant then moves on and goes into the evaporator. Again, it meters the expansion valve meters the refrigerant flow. It drops the temperature and the pressure of the refrigerant. Those are the valves that you see there. That's very typical, the H-block valves that we see in the trucking world. Valve at the top, that's a T-type valve. Where you'll find that typically is in truck sleeper vehicles that have a sleeper in the back, because there's typically a evaporator, another expansion valve, another blower motor in the back. So what goes wrong with expansion valves? Typically nothing. They're very bulletproof unless something else takes them out. And that something else is typically system contamination that plugs up, prevents refrigerant flow through the expansion valve. And that contamination is typically the desiccant that comes out of the dryer. If those dryers aren't changed and that desiccant begins to break down after holding so much water, turns into a sludge and is sucked out and drawn into the expansion valve. Some other things that can happen to them: the valve diaphragm, the big round part up on top, can get damaged, particularly when handling the valve. If it gets dropped on the floor, it can throw the valve out of calibration. So as the refrigerant leaves the expansion valve, it moves into the evaporator. And as we mentioned before, the evaporator is that cold thing that's inside of the cab that all of that heat that we talked about moves to. That heat moves from the cab into the evaporator. It absorbs heat from the cab as the refrigerant is evaporating, moving through. It functions just the opposite of the condenser. Refrigerant moves from the bottom to the top, and as it moves through there, it finishes evaporating, converting back to a gas. And when you evaporate something, it absorbs a tremendous amount of heat. It's moving all of that heat from the inside into the evaporator, into the tube, into the refrigerant inside of that tube, and is then carried on out of the system. The evaporator also delivers cold air to the cab. There's a blower motor behind that evaporator that blows air across that cold evaporator face. That's what blows the cold air that we're looking for out of the vents on the dash. It also dehumidifies the air. If you put something cold into a hot, humid environment, it begins to sweat. And in actual operation, this evaporator typically has water dripping off of it, sweat, water dripping off. That drips into the evaporator case that this thing is housed in up underneath the dash. one thing that you've got to check for is that the water that's building up in that evaporator case is actually draining out. There's a drain tube on there that drains that water out onto the ground. You may have seen that if you leave your vehicle idling in the parking lot for very long. Soon you'll have a little puddle of water up underneath the passenger side. That is the water that's dripping off of your evaporator and running out. Because what you don't want to happen is the drain tube to get plugged up, which was a fairly common problem, and it captures that water up inside of the evaporator case. And as we know, with standing water inside of there, it tends to start growing things, molds and algae and bacteria and that type of thing. And when that happens, you'll know it because you'll turn the AC on, you hit the button on the dash, and all of a sudden you're blasted in the face with that real nasty smell. Well, that's what's happening. That water is built up in there, and there's things growing in it. So you got to make sure that those drain tubes are clear and the water is coming out of there. So that, like we say, the refrigerant gains a tremendous amount of heat from the vehicle cabin as it changes state into a gas moving through that evaporator. So what goes wrong with evaporators? They're very protected. They don't typically get damaged from anything hitting it or whatever because it's in that evaporator case. What typically goes wrong with these things is they tend to get plugged up. Again, the airflow, just like the condenser, the airflow through this thing, if that blower motor can't get air through any dirt, dust, leaves, anything that's brought into the system, into the blower motor, and tends to get stuck on the fins. Again, just like on the condenser, if you can't get airflow through there, you don't get that nice vent cooling coming out of the vents. So you got to make sure there's also, a cabin air filter that's in there to filter out all of the dirt, dust, and whatever coming in so that it doesn't get into that wet evaporator and turn into mud, turn into sludge and dirt, preventing that airflow. Prevent leaks on these things, again, from the acid, from the refrigerant charged acid. When it gets too much moisture in it, they get attacked from the inside out. Evaporators tend to leak with little pins. Pretty easy to diagnose in today's world with the electronic leak detectors that's sold. They're very, very sensitive. You can actually take that probe of that detector, go straight into the dash vent, and if you got a leaky evaporator, it will begin to pick that up.